In Malaysia, we produce a lot of durian fruits every year, and this leads to the huge amount of durian husk waste. These durian husks are the major contributor to the environmental and the agricultural pollution. However, our research studies has uncovered a surprising solution, which is turning those durian husks into the dry cell. Hence, our product will be categorized into the SDG 7, which is our product is clean and affordable energy. Ladies and gentlemen, so what is dry cells? Dry cells is a biochemical cell that produces electrical energy through a chemical reaction. These cells are commonly used electrolyte gel, which is commonly used in our electrical devices, such as portable radios, hearing aids, and remote control. So, the part where we modify this dry cell is the paste in the dry cell, which turn the zinc into the biochar.
So now, we continue the problem statement. According to Dato Ibrahim Tuan Maha, Menteri Alam Sekitar dan Air, there is a lot of agriculture waste, which cause a lot of pollution in submarine, especially river. Nowadays also, conventional dry cell battery rely on non-renewable resources, such as zinc. These substances can release harmful chemicals that can destroy Mother Earth. Finally, public awareness regarding the environmental impact of conventional dry cell battery and agriculture waste is possible.
Moving on to the research methodology of our project, we have conducted 3 experiments to further indulge ourselves in the knowledge of our project. First of all, we conducted scanning electron microscopy, or SEM for short. This was conducted at University Putra Malaysia, where we scanned this surface area of the durian husk, bamboo and coconut to retrieve the data on the quantity and the size of the pores. Next, we also conducted EDX, which is Energy Dispersive X-ray. In conjunction to the SEM, EDX was also performed to analyze the elemental composition of the different types of biochars. Last but not least, we conducted the Fourier Transform Infrared Spectroscopy, or FTIR for short. We conducted this at the University Science Islam Malaysia, where we measured both transmittance and absorbance of different wave numbers of biochars. Alright, moving on to the biochar making process. As we have said earlier, we are making this biochar using raw durian husks. So, of course, first of all, we have to collect raw durian husks and dry them under the sun in order to stop microorganisms from inhabiting the biochar. Next, we have to cut them into smaller pieces and burn them in a beaker until it becomes crumbles of black durian husk. Next, we have to grind them in a mortar and pestle to become fine dust. And that is all. We have acquired biochar of raw durian husk.
Durian husk biochar, the Elon Musk of our pyrolysis, showing express lanes for the electrolyte movement, followed by the speedium in itself, the bamboo char, at a whopping 86.64%, followed by the coconut shell char at an amazing 65.77%. Now moving on to the FTIR analysis. FTIR analysis, a biocathode paste grooving with peaks resembling a psychedelic party of manganese oxide and potassium hydroxide. Now, moving on to the voltage, shall we? The one reigning supreme is the durian husk char at 0.97 volts, followed by the coconut shell char at 0.73 volts, and also the bamboo char at 0.62 volts.
In a world striving for sustainable solutions, biochars stand out as versatile and eco-friendly materials. What if we could enhance the production of biochars? By optimizing the production of biochars, we could maximize the utilization of eco-friendly dry cells. This will not only increase the stability and carbon content in biochars, but also enhance its application in powering electrical currents, which brings us to the next point, which is modifying the surface of biochars. One is through activation of potassium hydroxide solution before washing the sample with hydrochloric acid solution and deionized water, and the other one is the treatment of biochars with nitric acid solution through a reflux process. This will not only increase the conductivity of biochars and also improve the interaction with electrolyte.
In summary, the Ecopower synthetics project is a great step towards a greener future. We are using biochar from agricultural waste in batteries, which helps the environment. This is not just tech progress, but also a commitment to the planet. Our research shows biochar from durian husk, bamboo, and coconut shells can replace traditional battery materials, reducing pollution and resource use. We must protect our environment before it's too late. That is all from us. Thank you.